Should I start? Yes. Okay. Yes, this should be good. Okay. Sorry for the inconvenience, everyone. I didn't know that we have to record this using Zoom. So for those, my background is computer science. I've been working as a software developer for around 2.5 years now. Currently working at Bank. Today, I'm going to give you a presentation about TypeScript and what is it about. And so we're going to define the problems that we face today with JavaScript and how we can solve these problems. And then how can TypeScript help us evolve our development workflow. And with some examples, and then we'll go through some programming languages, type structures. Okay, so the problem with JavaScript, it's a weakly typed language. So we have that variables that have types. That is, when you have a variable, for example, this variable called something here, it can be assigned to anything, and then you can assign any other variable to that second variable having to declare the type. So, for example, you can have a variable called x that is a number, but then suddenly you can assign it to a string or a object or an array or whatever, right? So this always confuses the devs, especially when you have a big project, because when that happens, you will always, you won't know what's the object type that you're dealing with, right? So for example, you have here a very important object. One guy 2 years ago wrote it as this, contain a key called as and then a. So you just reference this by this.is.a, or you can just do a typo mistake like this one here, and you won't know that until runtime. So until you deploy your code and you actually test it, and then you'll be shocked that your code is not working and the management is complaining about you breaking the website, right? You don't want that to happen. Not that happen. Okay. So fact number one, JavaScript is not going anywhere. So JavaScript, like C for systems development, the ecosystem is very huge, growing every day. So it's here to stay. You cannot modify it because you cannot rebuild all of these legacy systems or libraries from scratch. But you can build on top of it, right? So the best time to get rid of JavaScript was 10 years ago. The second best time is today and now, right? So the proposed solution is we just take the same language that we have, the grammar of that language, and we extend it. So we don't modify the language itself, we just extend that language. And so here, for example, we have JavaScript code. For example, let y equal 4, which is a number type in JavaScript, and here we're assigning it as a string. This is confusing because when you define a variable as a number, you are most probably treating that variable as a number throughout your whole business logic code. When you reassign it to a string, however, this will cause lots of problems, such as the runtime errors. In TypeScript, what we notice here is we have this colon definition after the variable name, which here we can declare the type of the variable here. So I'm saying that the variable x is a number, right? So when I try to assign a string to that number variable, TypeScript will complain to me saying, hey, string is not assignable to type number. So it will stop me from doing such a mistake. It's also statically checked. That means, OK, you have a language server that can actually check your code while you're typing. In JavaScript, you don't have that. If you write this in JavaScript, there's no way the capability of the static checking. The TypeScript language server can actually catch this error and it will tell you, hey, this is not working, right? So this language extension is TypeScript. You can think of it as this Venn diagram here you have on the right. JavaScript is this small circle or set of grammar, and TypeScript is just extension of that set. So it's designed by Microsoft, and TypeScript is a compiled language. It's not an interpreted language just like JavaScript. So there's a compiler, we call it TSC, or TypeScript compiler. You give it TypeScript code, it outputs JavaScript code. In the JavaScript ecosystem and the whole, let's say, the community, they call this process transpiling. When you take the code from one version to the language to another. For example, taking it from ECMAScript 6 to ECMAScript 5, is also called transpiling. It's just a fancy word for compiling from one version of the language to another, right? So the compiler can catch these types error before runtime, and then that JS code will be executed on the runtime. That is, could be your Node.js environment or VX engine, however it is. And the TypeScript compiler also built using TypeScript. So when it started, it was JavaScript, but then they were able to type the TypeScript compiler also using TypeScript. So the language is bootstrapping itself. You can think of it that way. So you can write JS code in TypeScript, but not vice versa, right? So this also allows you to have autocomplete features that you cannot have with JavaScript. So this allows you to scale on scary levels, to be honest, with the projects I worked with TypeScript. You can have web apps with hundreds of pages, thousands of functions. You can just refactor that app without being scared from doing any single mistake if you are using the language correctly. So there are ways to shoot yourself in the foot using TypeScript, as we will see later on, inshallah. So yeah, it can give you confidence and error-free code refactoring. So here are some type examples. We've seen the number type here in the beginning, and the string type when we try to reassign the string into a number. We also have booleans, arrays, objects, any, which is like telling TypeScript, hey, don't treat this as TypeScript, just move on as JavaScript type, and many others that are out of the scope of this session. So here, for example, we have an account balance variable that is of a type number, and we are assigning it a number. Same thing with the Boolean, and it goes on. So here, for example, we have a string array. I can actually define strings within this array. So if I try to put or write a number or an object within that array, TypeScript will complain, hey, you cannot do that. The array must be of one type, right? And here we have a definition of an object. So this looks like the object that we're defining later on, but this is the type itself. So you're just saying here will be a string, here will be a number. And then the color will be actually a string, and here will be a number. If you try to assign it any other type, it will just stop you from doing that by giving you a compile time to yourself if you're using TypeScript. So if you're using TypeScript and going with any, might as well just install all the TypeScript code that you've written. Because when you do that, you can allow it to be assigned any other type, which you can define types either by using the inline colon operator, just like right, or you can use the type keyword to declare the type definition. So what do I mean by the type keyword? So remember these types that I've mentioned here, the colon ones. You can define these by keyword type. So I can say, for example, type role here is a bunch of strings. I will showcase this in the demo later. Here, I'm defining the type of a route, for example, and the route will be an object that contains a string and a roles array. And I've defined the roles types here at the beginning. That means when I say I have an array of role array in this example, that means I won't be able to assign that array any other here. That means that the array string types won't be exceeding those 3 types or 3 strings. I've defined the route array, and I have an object, which is the route type here, which has a 2 key. The type of that is a string. And then we have a roles array, which contains the department manager, which is the one defined here. Assume I don't have that string literal here. TypeScript will complain that, hey, department manager cannot be assigned to that type, which is a role array, as we mentioned here, right? This brings us to a very important subject. I've recently learned about this. So in programming languages and programming language design and theory, you have type systems within the languages. And there are actually 2 types of type systems. Most of the type programming languages are nominally typed. That means it goes by the name of the type. So for example, if there's a class point and there's another class myPoint, they both contain x, y variables as integers. You cannot assign an object of type point to another variable of type myPoint. It's impossible. You cannot do that, right? Because to the language, these are completely different things. This is called nominally typed languages. And TypeScript, and here's the fun part, it's structural. So the above example would work. Okay, so it's so the name is being used by the developer, but thrown during the compilation. So for example, here I have a type called point, another type called myPoint, and point here, point 1 is of type point, this one at the top, and then I was able to assign point 2, which is of type myPoint, which is the second variable, into point 1. So I was able to assign one type into another because they contain the same structure. Even though the object might contain extra variables, which won't be accessible during that time, during the using the object with TypeScript, but in runtime, in reality, it is there, right? So this is like one of those quirks of TypeScript. And then we have types and variable interfaces. I won't dive deep too much into that because of time limitation, but 99% of the time, you'll be using types instead of interfaces. You can declare interfaces just like how you declare types. There are three differences, which I won't mention here. But for your information, it exists. There's such a thing called, they're interchangeable. And then some developers would think that having TypeScript in the project eliminates all kinds of runtime errors. That's not the case. There are some classic pitfalls. If you have a system and you have variables running through that system and you have business logic within that system, yeah, that's fine. But the problem is all with the external data that you're having from external API calls and all of that. This will cause problems if you don't type check these at runtime even. Some people do that. Use like Zod and stuff like that, right? So if we can guarantee the structure of the response during the runtime, not the compile time, if we have data coming in from an API and we can guarantee that structure, then we can guarantee that the OR types that we've written during the compilation actually works during the runtime, right? So you can think of this step as input validation during runtime. So here, for example, I have an API call getting users. So users, the data could be an array. And if I have data 0, for example, the first element might have an email. In the future, it might not have an email. And that code will break, right? Some people, what they do is they have the schema types themselves are defined in another object, which are actually defined in the TypeScript namespace. So they have their own compilers or transpilers that take these types, convert them into JavaScript types, and then actually do the validation at runtime. So whatever you have either complies with the types you have, or you might throw an error at runtime showing that, hey, something went wrong, instead of working with the wrong with the wrong data type. You can write your own library if you do that. I've seen people doing that. It's like a quick job if you have done any sort of parser/compiler work before. Or you can use ChatGPT to generate a full-blown framework within a few minutes. You can do that. I've done that. Or you can use open source libraries for that, like Zod, right? So here, this example. So here we have, for example, a point. Contains variables x and y, but that this function returns this. It should return a point, right? Which contains x and y. But here I've said y instead of being a number. I've casted it as any. So you've like made TypeScript shut up. Don't do you ask TypeScript to not do this. Won't be a number, even while it's telling you this is a number, because you've assigned this string. So here, when you say the point and point.y, TypeScript says this is a number, but actually it is a string during runtime. Okay, so that's one point. Also, you have types auto-generation. So when you are dealing with big complex systems, just like I mentioned before, some people design systems that transpile or take the types that we have defined before and into objects, okay, that we'll be using for information, but hopefully I'll be able to cover all of it. Okay, so you lots of people rather not use TypeScript after all of this. They would like to go with regular JavaScript. How about that? They would rather be like this guy on the left, or telling me that JavaScript is better than TypeScript. I've seen this happening before. Lots of fights happen over coffee over this. So yeah, I have some code here. I want to show you the fancy stuff here. So for example, I have this fetch API function, right? It's like a very complex generic type, right? Like, okay, sorry. Can you see now? Okay. So I have this fetch API function, which I've defined using some generics, which I won't go over due to some time restrictions. But what I want you to see parameters that were selected, which is the service and the entity. That is, if you have a scheduling service, you have a user service, and you have inventory service. And each of these services can return you different objects or different data, right? So when you go through the fetch API, for example, if I say, hey, give me, I just want to have this here on the right, give me the, because I'm using them as type literals, it will autocomplete for me saying, hey, you have, give me the inventory service. And then I'll be asking it for the second parameter, give me the second object, which is either the item or the storage unit, which is actually defined here on the right, right? So I've defined these types on the right. And then I have this item, and then the result type will be actually of type item. It returns the promise of a stock and a name, which is the item itself, right? So I can do something like that, say a storage unit, and this will be a promise of a storage unit. And then using that, actually do what we mentioned before, using the service and the entity here by doing the runtime validation, because we have the types here in the types namespace, and then we can take these types namespace, convert them into the JavaScript space, and do the actual runtime validation here using the service variable and the entity variable defined on top here, which are generics at the end of the day, right? So yeah, that's one part. There are other complex types, but I won't go over them. Let's go here. And yeah, so some of that might be quite advanced. It might be confusing for beginners, but trust me, it's worth it at the end of the day if you are dealing with JavaScript and Node.js/frontend code. TypeScript has more to offer than this. This is just like the tip of the iceberg. Some people actually have what they call TypeScript battles. There are some GitHub repositories about that, where they actually define full chess games using TypeScript types. People do that, just for fun. Yeah. Yeah. If a well-written type is a well-formulated problem, which is a half-solved problem. If you don't know how to type what type of variable you're working with, that means you don't know what you're doing most of the time. You're just trying to finish stuff, right? If you can't type that variable, that means you know what you are doing, which is a half-solved problem. You just solve the problem already. So for me, for example, when I deal with that, I just go and write all of my types before I write any kind of JavaScript code. Just formulate my problem. If I make this concrete without changing it, most of the time, I won't have to change it again because my types are well written. So some references, the most, here are the references. I highly recommend the TypeScript GitHub wiki. So if you open the TypeScript language GitHub repo, there is a wiki over there. You can go and read it. Very informative. And that's it. Thank you.
Questions and answers are not taking time.
Okay.
Since you're sitting out,
feel free to approach me.
For those on Zoom, there's a Q&A section, so you can use that on Zoom. Okay, so I'll give you the questions and we can answer them later.
Inshallah.
If somebody
Okay.
asks.
Thank you, everyone.
Thank you.